Hello and welcome to our very first educational video on IMS. It's called IMS Fundamentals, an Introduction to IMS. My name is Deepak Kohli. I'm a senior software engineer at IBM, and I'm going to be talking about the IBM product called IMS. Now, before we do that, whenever I start learning some new technology, the first question I ask is it relevant? Is it important? And so the same question applies here. Is IMS important? Why should someone want to know about IMS? So with that, let's see if we can address this question. Believe it or not, you have been using IMS. You may not know this, because IMS has been part of our daily lives for decades. If you've ever used an ATM, if you've ever dipped your card and did some banking transactions, behind the scenes, in the background, there was an IMS system that was processing these ATM transactions. If you've ever done online banking, if you've purchased an item from a retailer or did online banking, for example, behind the scenes, in the background, is an IMS system that was processing your online banking transactions or your purchases from a retailer. Automobile manufacturers use IMS to control their inventory, to keep track of the orders that come in. If you've ever gone to a doctor, well, visits to a doctor generate patient records, generate insurance claims, and those insurance claims and patient records in the background typically are processed by an IMS system. Trains or railroads use IMS. They use them for scheduling trains, for keeping track of which cars need to be on which specific trains. So railroad companies often use IMS systems. And of course, many retailers use IMS to control their inventory and of course to keep track of orders. And so we don't even think about this IMS system in the background. We don't even think where the data is and whether or not the data is safe. In the background, working magically, is this system called IMS that is making sure that the transaction gets processed, making sure that the data has integrity. And so IMS has been part of our world, and we continue to use it. Now, just to give you some statistics, IMS runs the world's most critical workloads. We have about 2,000 or so customers worldwide that run IMS. 75% of the top 100 banks worldwide run IMS. The top 5 U.S. banks, believe it or not, run IMS. Top 5 European banks run IMS. So hopefully by now I've convinced you that IMS is very, very important. Here are some more statistics. 16 petabytes of production data are managed by IMS. We have one customer where $3 trillion per day are transferred through their IMS system. We have a customer who's got 500 million accounts for their customers, all managed by an IMS system. And some 300 plus million users every day are working on an IMS system. And this is the catch, with IMS version 13, which came out last year in 2013, we can now process 100,000 transactions per second on a single IMS system. We're not talking clustering. We're not talking, several IMSs working together. We're talking about one single IMS system processing 100,000 transactions per second. And actually, to be honest with you, this is just a marketing thing, 100K IMS. The actual benchmark numbers were 117,292 transactions per second. So with the latest version of IMS, which is IMS version 13, which came out in 2013, we are able to process well over 100,000 transactions per second. And here on this next page is a small sampling of some of our customers that use IMS. In fact, I think it's safe to say that 95% of the top 1,000 Fortune companies use IMS for their operational data. Now, if you ask these top 1,000 Fortune companies, why do you use IMS? And you will hear answers like this: unparalleled combination of high performance, scalability, rock-solid reliability, and runtime efficiency. IMS uses less disk space and CPU than other database managers. And IMS delivers extremely high performance and availability at a very low cost per transaction. And that's the key reason where, you've got companies, big banks, insurance companies, manufacturers that continue to use IMS and have been doing it for decades. So this is sort of the iconic reputation, if you will, of IMS. So hopefully I've convinced you that IMS is very important. It's important in our world, and most of the industries out there use IMS. Now, it's important always to understand how things got started. And because when you understand how things got started, then you understand what the nature of that thing is or that product is. And so I think we should do the same here. Let's understand first, before we dive into and try to figure out what IMS is, let's understand the history of IMS. Why did it get started? What was the problem that existed that they were trying to solve? So let's do that. Well, it all goes back to the 1960s with President John F. Kennedy. President John F. Kennedy on May 25th challenged the American industry to send an American man to the moon and return him safely to Earth. And this, of course, started everybody working on trying to get a man to the moon. And so in 1965, this company called North American Aviation, which would later become Rockwell International, won the bid to build the spacecraft to send the man to the moon. And they partnered with IBM to create an automated system to manage the parts of the spacecraft, to manage the large bill of materials for what was known as the Apollo spacecraft construction. And so in 1966, the design and development of this computer system began. And this computer system back then was called ICS/DLI. ICS stands for Information Control System and Data Language Interface. And the founding development team for this ICS/DLI system included 12 members from IBM, 10 from North American Aviation, which later became Rockwell International, and 3 from the Caterpillar Tractor Company. And in 1968, just 2 years later, ICS is installed, and on August 14th, the first IMS ready message is displayed on an IBM 2740 terminal at the Rockwell Space Division in Downey, California. And then just a year later, in July of 1969, Apollo 11 landed on the moon's surface. So, and then later on, that started, if you will, the journey for IMS. From 1969 on to 1970, IBM took ICS and relaunched it and gave it a new name. It was then called IMS 360, or Information Management System /360. 360 being the mainframe system that it ran on. So IMS, if you think about it, IMS helped NASA fulfill President Kennedy's dream of sending a man to the moon and returning him safely back to Earth. So that is how IMS got started. And let's look at what becomes part of what I call the IMS DNA. The IMS was really developed for this large bill of materials for the Apollo spacecraft construction, keeping track of the parts, keeping track of the relationships between the part, what part goes where, and what the relationships are. And in a bill of materials are hierarchical in nature, with the top level representing the final product. And back then in the 60s, we were talking about 2 million parts for this Apollo spacecraft. And so there had to be this system that could keep track of this large number of parts and their relationships and what part goes where. And also think about this. This is back in the 1960s when, we didn't have fast, large disk files. In fact, the first system that was developed, the information was put on tape. and then they found that the tape was so slow, and then the disk files that first came out were very, very small in those days. And so when they were developing this system, which later became IMS, there were certain things they had to do given the computing resources that were available in the 60s. For example, because the disk files were small, you see, they had to have efficient ways of storing the data. They had to have efficient ways of retrieving that data. And also, integrity was very important. You know, you couldn't just say data was lost or corrupted or compromised, because if that happened, then you were compromising the safety and integrity of the Apollo space mission, right? Also, there had to be recovery capabilities built into the system, because if a DASD device failed, for example, there had to be a way to recover that data, right? Also, the IBMers at that time understood that the technology, the hardware technology, was going to evolve, and disk files were going to change, and they were going to become faster and bigger and stronger. And so they had to have a separation of the application code from the data storage. So if you changed how data was stored, you shouldn't have to go in and change your applications. Now, of course, today, you know, we kind of expect that from database management systems. That's sort of rule number one in database management systems, that there has to be a separation of application code and data storage. But back then, this was innovation at its best. This was the first time a database management system was being developed. And also because they knew that over time, disk files or devices were going to change, they had to have device independence. So this then became what I call the DNA of IMS, the efficient storage of data, the efficient retrieval of data, the preserving data integrity at any cost whatsoever, being able to recover that data, being able to provide device independence. This is what made IMS. And this is the reason the largest banks in the world continue, decades on today, continue to use IMS. So this is what I call the DNA of IMS. And you found it back then in the 60s, you found it in the 80s and 90s, and even now in the 2000s. We continue to make sure that we don't compromise in the area of efficiency of storage and retrieval, in the area of integrity, in the area of recoverability. This is the DNA of IMS, if you will. Also, the Apollo effort was worldwide, and so they needed an online update and inquiry capability on the status of critical parts of the Apollo project. So you needed to have an online access to the data. And so, believe it or not, the first transaction monitor, or in those days they didn't call it a transaction monitor, they called it a teleprocessing monitor, was born. And so this was the first time ever in computer systems back in the 60s, a transaction monitor was born. So I view IMS as the godfather of database management systems and transaction monitors, if you will. So that's sort of the history, and I wanted to sort of bring that out because as we go through IMS, as you'll see when we talk about IMS, that these characteristics of IMS are always going to be there. Now, let's talk about what is IMS then. IMS stands for Information Management System. It's an IBM software product, or IBM program product as they call it, and it's actually two products. There's what we call the IMS Transaction Manager, or IMS TM. By the way, in the 80s and 90s, they used to call it IMS DC, Data Communications, and then of course if you go back to the 60s and early 70s, it was called IMS TP, Teleprocessing. But nevertheless, a transaction manager, which manages transactions, and we'll talk about what that means in just a bit. And it's also an IMS database manager. It's a database management system. And it's a specific type of database management system. It's a hierarchical database management system, as opposed to, say, a relational database management system. So it's two products, IMS TM and IMS DB. All products run on the mainframe only. There's no version of it that runs on some other platform. They all run on the mainframe, on the ZOS operating system. And of course, the products have been around for a long time. They have a proven track record of 46 years. Now, typically IMS is what's known as a MLC product in IBM. MLC means monthly license charge product, which means, the more you use, the more you pay. However, recently we've come out with some other variants of IMS, and these are called IMS OTC products. OTC stands for one-time charge. In other words, you pay for this once, you get the product, and then you use it as much as you want. So there's an IMS Database Manager Value Unit Edition, or IMS DBVUE, and there's an IMS Transaction Manager Value Unit Edition, or IMS TMVUE. So you'll hear these terms. Sometimes you'll hear a customer say, well, we're using an IMS DBVUE. What that means is they're using an IMS Database Manager, only they bought the one-time charge product as opposed to the MLC version of it. Now, the functionality of a VUE is the same as a non-VUE. In other words, it's not like you get anything less. You get all the same functions that you would get in a non-VUE IMS. The only reason IBM decided to provide these VUE options for IMS is to provide an alternative and attractive pricing option for new workloads. Workloads coming in, say, through mobile, or workloads dealing with analytics or big data workloads. And that's why they provided these VUE options of IMS so that customers could continue to use IMS with these new workloads. The most current version of IMS is IMS version 13. Oh, by the way, there's a typo on my slide there. Most current version of IMS is IMS version 13. It was announced in October 1st of last year and became generally available on October 25th of last year. That's 2013. So, with that said, let's give you a little bit more detail on what IMS TM is and what IMS DB is. So IMS TM stands for IMS Transaction Manager. And as the name implies, it manages transactions. It manages the receiving of transactions. It manages the processing of those transactions. It manages sending replies back to where the transactions came from. So that leads to the next question. Well, what is a transaction? I think the simplest definition of a transaction is a small unit of work that needs to be performed real time. So typically, you've got devices that are connected to an IMS system, and sitting at these devices, or terminals, for example, are human beings, and they're entering transactions, and then those transactions are processed, and the reply goes right back to the end user sitting at those devices. A really good example of a transaction would be an ATM transaction. So when you go to the ATM and you dip your card and you say, give me $100 for my checking account, that's a transaction. And when you dip your card, you don't want to wait for 15 minutes to get your $100 from the checking account. You want it within seconds. You want the money and you want your receipt, and boom, you're ready to go. And so a transaction manager's job is to receive these transactions and make sure that these transactions don't get lost. Make sure that they're processed in an orderly fashion. Make sure that the replies are sent back to the same end user who entered those transactions, right? So that's basically what a transaction manager does. IMS is a transaction manager known as a queuing transaction manager. What that means is that transactions, when they come into IMS, they are queued to be processed. And then later they are processed in a priority fashion. And once they're processed, the reply is then immediately sent back to the end user. So that's what a transaction manager is. And in our next video, where we will talk about the online architecture, we'll talk about an IMS TM system in a lot more detail. IMS is also a database system, and so a few words about a database system. By now, I think nowadays everybody knows what a database system is, but in the 60s and 70s, this was a new thing. And I think a very nice, concise, simple definition of what a database system is, it's a system that allows multiple independent users to have concurrent access to a central repository of information. That's it. Very simple. One central repository of information, one place where you know the data resides, where you know the data has integrity, and everybody can access it at the same time. So the advantages of a database system is you've got centralized files for all application or centralized information for all applications. You eliminate duplicate space and duplicate data, and you have a single information source that provides complete, accurate information for processing. Now here's an example, a pictorial example, if you will. I've got a database which has got data, and the engineering application and the inventory application and the accounting application. They can all access the data at the same time. And of course, it is the database management system's job to make sure that the integrity of the data is preserved. So if I've got two different applications at the same time, going against the same data at the same time, and trying to update it, we have to make sure that updates by one program are not lost because another program was trying to update them at the same time. And all that locking and controlling that's all handled by the database management system, if you will. So now let's talk about the IMS database in a little bit more detail. As I mentioned, IMS is what's known as a hierarchical database management system, as opposed to, for example, relational. DB2 is a relational database management system. When we talk about relational database management systems, data is stored in the form of tables. Conceptually speaking, data is stored in the form of tables. In a hierarchical database management system, conceptually speaking, data is stored in the form of a hierarchy. So here's an example where I've got an IMS database. It's an employee database where we keep employee information. And the data is stored in the form of a hierarchy. And let me explain. In an IMS database, you have multiple database records. Each database record is made up of smaller units of data known as segments. So in my example here, employee is a segment, salary is a segment, address is a segment. And these segments are arranged in a hierarchy. And so employee is a segment, salary is below the employee segment, address is another segment that's below the employee segment. And if you will, it's sort of like an inverted tree structure. The employee is considered the root segment, and then underneath the employee we've got the salary segment and an address segment. And any segment, by the way, in an IMS database, any segment can have 0 through n occurrences. So in this particular case, an employee who has moved around, who has had different addresses, may have multiple address segments under the employee segment. The segment itself is further broken down into smaller units of data known as fields. So the employee segment here is broken up into smaller units of data. There's the employee number, and then they're followed by the employee name, which is 30 bytes long. Then you have the department, which is 2 bytes long, and then the date the employee was hired, that's 6 bytes long. So this is sort of the structure of a IMS database. It's a hierarchical database, and every database record is made up of one or more smaller units of data called segments, and each segment is further broken down into smaller units of data known as fields. Typically, application programs in IMS request segments. So when I'm accessing the data, I would access one particular segment. I may want to get the employee segment whose name equals John Campbell, for example. So segments is typically the unit of request by an application program. However, it is possible for an IMS application program to request more than one segment in one request. And we'll talk more about that when we go into IMS application programming in another video. Now, how do you access the data in an IMS database? In relational databases, the language that they use is SQL, Structured Query Language. In IMS, the language that they first started with in the 1960s, which they still continue to use today, is known as DLI, Data Language Interface. It is a proprietary language designed for IMS, designed for efficiency, designed for speed, and that's the language that folks have been using in the 60s, in the 70s, in the 80s, all the way through the 2000s. In addition, a couple of versions back, we started giving our customers the ability to access IMS data via JDBC calls. JDBC is basically SQL calls from a Java environment. And of course, you can issue SQL calls to access IMS data. So you know, there are several different ways that you can access IMS data. You can use DLI, you can use JDBC, you can use SQL. And I believe IMS is the only non-relational database that you can access using SQL. The IMS application programs can be written in Java. They can be written in Enterprise COBOL for ZOS or PL1 for ZOS, or the IBM mainframe assembler language, or C or C++. Now, let's talk about IMS product implementations. How do IMS clients typically use these products? So there are different combinations that customers use when it comes to IMS, and that's what I'm going to cover on this particular page. Some customers will use both IMS TM and DB. IMS TM will be used for, processing of transactions, and IMS DB will be used to store IMS data. This is known as an IMS DB-TM environment, or in the 80s they used to call it DB-DC. So you'll often hear, when you're speaking to somebody who works in IMS, they'll say, yeah, I work at a DB-DC shop. What they're saying is that where they work, they have both IMS DB and they will have both IMS TM. Some customers will not use IMS TM for transaction processing, and they'll use CIX. CIX is another transaction manager that IBM sells. And so they'll use CIX for transaction processing, but then they'll use IMS DB to store the data. So this is called a DB control environment, DBCTL, or CIX DB control environment. So if you hear that term, you're at a conference and somebody says, yeah, we're a CIX DB control shop. What that means is they're using CIX for transaction processing and IMS DB for storing of the data. Some customers will use IMS TM for transaction processing, but the data will be stored in DB2. This is called a DC control environment, DCCTL, where they're using IMS TM for transaction processing and DB2 for storing of the data. So there you have it. That's sort of the different product implementations of IMS. In our next video, which will be titled IMS Fundamentals Part 2, IMS Online Architecture Overview, we'll talk about the IMS Transaction Manager Architecture, and here's a picture of what this looks like. We'll talk about the IMS Control Region, we'll talk about DBRC, we'll talk about something known as DLI Separate Address Space, and then we'll talk about the IMS Dependent Regions, MPRs, BMPs, IFPs, JMPs, JBPs, and we'll look at this in a lot more detail in our next video where we'll talk about the IMS Online Architecture Overview. Now, I think I've gone through 26 or so slides, and I haven't mentioned the word social, so it's important that I mention this. Everybody nowadays is on social media. Well, guess what? IMS is on social media. We're on Facebook. We often have tweets going out. We're on LinkedIn. We have a newsletter that we've been publishing for I think over a decade now. We have regional user groups that continually meet and talk about various topics in IMS. And on this page, I've got the links to our Facebook page, our Twitter account, our newsletter, our regional user groups. So feel free to visit us, follow us, and stay connected. If you have any questions, please post them on the IMS forum on LinkedIn, or I think I put my email ID on the title page. You're welcome to email me. And I'm Deepak Kohli, and I will see you on video 2. Thank you. Bye-bye.